controlling engineer. I'm also a former atheist. And my time in the military space program was interesting in that I went into that position as an atheist and an evolutionist, and came out of it as a creationist and a Christian. In that order. I became a creationist first, and then that led me to being a Christian afterward. And I like to mention that because there are many in the creation evolution discussion who say that those of us who are creationists because the Bible requires us to be. That if we didn't have these blinders on that our faith puts on us, that surely we would be able to see all this evidence for secular origins, evolution, whether cosmic, biological, or whatever. I'm one of many for whom the opposite was true. I became a creationist first because of what the evidence said, and then a Christian afterward. Now, being persuaded of creation is not sufficient to make one a Christian. That's the work of the Holy Spirit. I mean, there are Muslims who believe in creation. But again, I like to mention that just to point out that this is not only a blind faith issue. I'm going to argue that if you believe in science, Christianity specifically is the only consistent belief you can have in origins. And that's sort of a bigger topic than what we'll have time to do tonight. But we are going to touch on a little bit of this as we go through. Now, creation talks tend to come in a couple of different flavors. There are some that will promote the biblical model of origins and talk more about that. There are some who promote biblical authority. And then there are those who debunk the secular model. And as you can see by our title here tonight, I'm going to spend most of my time this evening debunking the Big Bang model specifically. And the Big Bang model is claimed to be the explanation for where the entire universe came from. Everything we see. That includes not only us here in this room and the planet we're on, the galaxy we're in, the galaxy cluster that the galaxy is in, on it goes. The entire universe supposedly formed in this Big Bang event roughly 14 billion years ago. We're going to look at that, though, and see how well that really fits the evidence. Now, there's two basic interpretations when looking at the sky and contemplating the universe, and that's it was created or it wasn't. Now, there's lots of different variations on it wasn't. There's lots of non-creation explanations you can come up with, but that's the two basic options, really. There's either a God who did it or there's not a God who did it. Now, the creation option, of course, says, in the beginning, God created the heavens and the earth. That's pretty straightforward. Genesis 1, most of us are familiar with that. Of course, though, in our society, for the most part, we're told that's not an allowable explanation. Why is that? Well, because this is a supernatural explanation. Now, the word super means above or beyond. So that which is supernatural is that which is above or beyond the natural world, above or beyond nature. And because the Bible has a supernatural account of the universe's origins, we are told that it's illegitimate to invoke this in civilized company, right? We're told instead that the only allowable way to look at things is naturalism, the idea that only natural explanations are allowed to account for everything we see. In fact, there are many, unfortunately, Christians who are thinking more in a naturalistic worldview than in a biblical worldview. And this is also a good time for me to mention, I'm going to spend most of my time tonight talking about the secular Big Bang model. There are many Christians who promote the Big Bang as the way that God did it. I don't think that's necessary, and I think it's wrong for some reasons, as we'll see. But keep in mind, if some of you here believe God did it through the Big Bang, I'm not addressing your view specifically. I'll touch on this a little bit at the end, what relationship Christians should have to the Big Bang model. So most of our time here tonight is going to be spent on the secular version of this, though. Just want to make that point. So the timeline of the universe overall is supposed to be about 14 billion years, give or take. 14 billion years ago, there was supposedly this Big Bang event. And in this Big Bang event, we had radiation, which turned into hydrogen and helium gas. That then formed itself into stars. The stars then gathered themselves together into galaxies, one of which is our own Milky Way galaxy. Within the Milky Way galaxy, 4.5 billion years ago, give or take, there was a swirling cloud of gas and dust that formed our solar system, and within the solar system is the planet Earth, where we are today. Now, we know that the Earth exists because here we are, but what about the rest of this timeline that's presented as history? Well, we can look at each stage of this. I have a whole talk, and indeed an entire DVD, as Heinz mentioned, just on the formation of the solar system. We're told that there was a swirling cloud of gas and dust, and from this cloud of gas and dust came all the planets, and along some other miscellaneous objects like asteroids, comets, and so on. Well, that doesn't work for a whole bunch of different reasons. The DVD itself is almost 2 hours long, And that goes planet by planet through the solar system. Each one actually discredits that secular model in a different way. In many cases, more than one way per planet. That's a lot of fun, but strictly speaking, it's out of our scope tonight because that's not really part of the Big Bang model. So I'll just note that that part of the model doesn't work from the secular side of things. Looking further back, we see star formation is an integral part of this model as well. Now we're told that stars form from gas clouds that collapse under gravity. What people often don't mention in science programs and cosmos and whatever else is that there's other forces in these clouds, other things going on besides just gravity. One of them is gas pressure, which actually forces the cloud to dissipate. Turns out gas pressure is actually going to be more powerful than gravity without some unusual circumstances. So left to its own devices, a gas cloud in space will dissipate, not form stars. Secular people do have ways of overcoming this, but all the ways they have thought of to form stars all require old stars to already exist. So there does appear to be some star formation going on in the universe right now, but where the first generation came from is a question that the secular side can't answer. And of course, if you can't account for star formation ultimately, then of course you can't account for galaxies either, which means that this part of the secular timeline doesn't do so well under further scrutiny as well. But again, this is also out of our scope because in our talk tonight, we're going to go all the way to the very beginning of this model, the Big Bang itself. See, where did the whole universe came from? Where did this stage that all the other pieces are moving around on form? Well, if you look around internet and whatnot, you'll commonly see diagrams like this. It's difficult to display a three-dimensional event, of course, in a two-dimensional picture. But the basic idea is at the very beginning, this is early and this is later, so this took billions of years going left to right. There was this Big Bang event from a quantum fluctuation of some kind. We'll talk more about that. And then it quickly ballooned outward in size, and then as we went forward in history, you see the universe continued to expand because the cross-sectional area here gets bigger and bigger. So at first there was this radiation which formed this cosmic microwave background, which we'll also talk about. And then we see gas gradually forming into stars, forming into galaxies, and so on. Now in our time tonight, I'm going to take three different stages of our discussion. First of all, I'm going to show you why it is claimed that the Big Bang is good science, that it's a good scientific model. We'll talk about the pieces of evidence that are used to support the Big Bang model and the evidence that is presented for us to persuade us that indeed this is how the universe got there. Then I'm going to look at the Big Bang in a little more detail and some of its steps, and we'll see it's actually not good science, it's actually bad science. Then we'll look at the implications of the Big Bang model, go a little deeper than most people will do, and I'm going to argue that the Big Bang model is not only not good science, it's not only bad science, it's actually anti-science. That the Big Bang model, if you take it to its logical conclusions, denies the fundamental things that must be true in order for science to work. Now that's a pretty bold statement, so we better get started. So, is the Big Bang good science? Well, before we can answer that question, we have to ask, what is the Big Bang? Well, what we're being told is this, that in the beginning, there was this explosion of some kind coming from a fluctuation, and then from that formed gas, and from the gas formed stars, and so on, as I've already mentioned briefly. Now, as we study the cosmos, a lot of this goes back to the work of a man named Edwin Hubble, very accomplished astronomer, and of course the Hubble Space Telescope was named after him, along with some other things within astronomy. And Hubble himself was kind of an interesting character. He was born in Midwestern rural USA, went to England for some of his college work, adopted a fake English accent for the rest of his life, even after he returned to the States. Liked to walk around in a tweed jacket and smoke a pipe and so on, so he's a little bit of a character. But he was one of the first ones to realize that starlight from faraway objects is almost all redshifted. Now, what does redshifting mean? Well, a lot of us are familiar with the idea that if you take a prism, you can shine white sunlight through it, and what does it do to the light? It breaks it up into all of the various colors, right? So you might have heard in your science class that white light is a combination of all different colors of light. Add them all together, you get white, and then the prism will break them back up again. Well, astronomers have instruments that do similar things. If you have a good quality one, better than an ordinary prism, and you take a good look at the spectrum that's produced, for example, if you get sunlight through some of these instruments, you'll see something like this. Notice there's all the visible colors that the human eye can see, but notice also there's some colors missing. These black vertical lines. These are specific wavelengths of light that are not in sunlight. So what's going on here? Well, Since the 1800s, it's been understood that when light passes through, like a gas, for example, the chemical composition of the gas will subtract certain colors or certain wavelengths from the light. And I don't need to explain why. You can look it up in a physics book if you're curious. But point is, it's well understood why this happens. And it's also understood why sunlight has the specific pattern that it does. It turns out that we can actually analyze the chemical composition of the sun's atmosphere by looking at which colors are missing in the spectrum. Because the specific elements actually, as I said, subtract colors as the light travels through the sun's atmosphere on its way to us. In fact, piece of scientific trivia, the element helium was discovered on the sun, specifically in sunlight, before it was discovered here on Earth. They were analyzing these patterns of lines and saying, okay, well, we know what these are, we know what these are, we know what these are, and they were left with a set that said, we don't know what this is. Well, that turned out to be helium, named after Helios, the sun god, like I said, trivia. So why am I talking about this? Well, because when we analyze starlight from, say, faraway galaxies, we see a similar pattern. You see how this pattern here is pretty close to that one, right? So that tells us that distant stars are pretty close to our sun in chemical composition. But notice that that pattern is shifted over toward the red end of the spectrum. You see that? Same pattern, but it's shifted over. That's because it is understood that the light source is moving away from us. So if a light source moves away from you, in effect, the light wave gets stretched out. You can think of it that way. And when you stretch out a light wave, it turns redder. Conversely, if the object is moving toward you, you can think of the light wave sort of bunching up, and then it will get shifted toward the blue end of the spectrum. So when we look at distant objects, with a few exceptions of some things that are close by, everything else is redshifted. And Hubble was one of the first ones to really put all this together and say, all these distant objects, the more we look at, the more we see they're all redshifted. And in fact, the ones that are further away from us are redshifted more. Now, there's a couple of different ways to interpret this. He chose to use something called the cosmological principle, and we'll probably touch on this again later. But what he basically inferred from all this is that all objects, heavenly objects, are moving away from each other. And no matter which one you were in, these are galaxies, by the way, no matter which galaxy you were in, you would see all the others moving away from you radially. Now, if every galaxy is moving away from every other galaxy, I shouldn't say every, because there are some that are bound together in clusters and so on, but I'm talking on a larger scale. If all the various objects are moving away from each other, now mentally run that movie backwards. If they're moving away now, then in the past they used to be further together, right? So keep running the movie backwards, and you eventually get to a point where all the galaxies were at the same place. And this is the fundamental idea behind the Big Bang model. That if everything is moving apart today, then earlier in history they must have been closer together. You go back 14 billion years or so, they must have all started at the same place, and that was the Big Bang. So redshifts are thought to be very strong evidence for this Big Bang idea that the universe started at a very small point and then blew itself outward. Evidence number 2 is the abundance of light elements. The Big Bang model accounts for how much hydrogen there is in the universe and how much helium and a few other things, and these ratios of these elements are very closely matched to that which the Big Bang model would produce. So this is also viewed as being excellent support for the model, that the Big Bang model produces, quote unquote, the same ratios of light elements that we see in the cosmos today. Evidence number 3 is the cosmic microwave background. You've probably seen this in a news release or on a science program or something. This is a sky map that shows temperature differences. It turns out that there's very low temperature radiation coming to Earth from all directions in space. Now, the color differences here are minute differences in temperature. This is important because this is, unlike the first 2 items, which were already known at the time the Big Bang model was developed, this was predicted before it was found. And it was predicted based on the Big Bang model. So people were thinking in terms of the Big Bang, and a few astronomers said, you know, if this is true, then that should have left this leftover pattern of radiation all through the universe, coming at us from all directions in space, at only a few degrees above absolute zero. And sure enough, in the mid-60s, this pattern was found. So this was a prediction made based on the Big Bang model that was then found. Now in science, it's one thing to say, my model explains all these things we already know. But you're not really worth anything until you make a prediction that can be confirmed or disconfirmed through an experiment or through an observation. So in this case, the Big Bang made a prediction that we would find this, and then we found it. So excellent support for the Big Bang, right? So those are the three main lines of evidence for the Big Bang. And there's other stuff as well that's minor, but those are the three big ones that the whole model is really based on. Does that mean it's good science? Well, not necessarily, because there are other explanations for these same lines of evidence. There are other cosmologies that also explain cosmological redshifts. There are other ways of looking at things with the abundance of light elements, and in fact, some people argue that the Big Bang doesn't actually produce as good of a match with light elements as is argued. Specifically, there's a problem with lithium. And as for number three, well, when we first found the I shouldn't say we, I wasn't born yet when they first found this in the early 60s. But when it was found, our instrumentation was very crude, and they understood that there's something out there but couldn't measure it very well. As our ability to measure it has gotten better, its match with the Big Bang model has gotten worse. The latest measurements come from the Planck spacecraft, and Planck has revealed something that was hinted at before in the data, but the data weren't really good enough to show it. There are patterns within the cosmic microwave background that should not be there if the Big Bang model were true. One particular pattern is called the axis of evil. This line that goes through, and it's called, as you can probably guess, the alignment in the CMB going through space is called evil because it undermines ideas about the standard cosmological model, from this quote right here. So my point is, there are evidence that they will present to us claiming that the Big Bang is good science. Upon further examination, though, that evidence doesn't really necessarily hold up. That in itself isn't enough to discredit, may not be enough to discredit the Big Bang model fully, so let's go further and see, is it really good science or bad science? What does the model say overall? Well, supposedly in the beginning, there was nothing, and then it exploded. Well, what exploded? Well, nothing exploded. Nothing exploded and made everything, which is why there's everything rather than nothing. Now, we're getting from science into philosophy here, because how do we go from nothing to everything? Because nothing can create nothing, right? Nothing can do nothing. From nothing, nothing comes. Now, some people will say, well, if you wait long enough, even the extremely improbable will eventually occur. Well, that doesn't work here, because everything coming from nothing is not improbable, it's impossible. So it doesn't matter how long you wait, the impossible still will not happen. Nor, by the way, can you wait long enough before the Big Bang, because the Big Bang supposedly formed space-time, which includes time. So there was no before the Big Bang, there was no then. So you can't wait long enough because there's no time within which to wait, right? Nor was there a place, by the way. Do the secular people have answers to this? Well, some of them will say yes. They will say yes, no problem. You will see books like Lawrence Krauss. He says a universe from nothing. He wrote a whole book on how a universe can come from nothing. Well, you dig into Mr. Krauss's book and you try to find out exactly what he's proposing. It's difficult because he doesn't like to come out and say it, but eventually he says the quantum field fluctuated and then formed the Big Bang. Well, what is a quantum field? Is a quantum field nothing? No, a quantum field is something. Now, he argues it's nothing because there's no particles yet. Well, but in particle physics today, a quantum field and particles are just two sides of the same coin. A particle is basically a knot in a quantum field, if I can abuse the English language here a little bit. But my point is, ask a physicist, a quantum field is most definitely not nothing. It is something. Mr. Krauss further in his book then appeals to quantum gravity to explain how all this could have come from, although he's very vague on details, and for good reason. Physicists don't have any theories of quantum gravity. So the refutation of this idea is that coming from a quantum field doesn't solve your problem, because a quantum field, something that obeys a Schrödinger equation that I'm showing you here, is not nothing. It is definitely something. There's also the question of nothing forming everything all by itself without anybody else being involved. See, something can't create itself now, can it? Because in order to create something, the creating thing must first exist. But if it hasn't created itself yet, then it doesn't exist. So self-creation means it must exist before it existed, which doesn't make much sense. Is there a solution to this? Well, yes. Physicists will tell you, like Stephen Hawking here, because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, and why we exist. He goes on to say, the laws of gravity and quantum theory allow universes to appear spontaneously from nothing. Notice he said universes, by the way, in the plural. We'll talk more about that later. But he's appealing to the laws of physics. Laws of physics allow things to create themselves. Well, what is a law of physics, though? Is a law of physics a thing? Can it create anything? If I open my fingers, what's going to happen to the laser pointer? It drops. Why? Gravity. What is gravity? I don't see gravity. I don't feel anything here. Is gravity a thing with the power of creating something? Or is gravity our description of a pattern of behavior that we notice in the universe? That whenever we do an experiment a certain way, a certain behavior occurs, and we notice that pattern, we do experiments to fill in how it works, and then we quantify that pattern into a law of physics. That's really what happens, right? A law of physics is not a thing that can create something. It's a pattern of behavior, the way the universe works. Well, before the universe existed, there can be no pattern of behavior for the universe, can there? Right? So to appeal to a law of physics to create something doesn't make any sense now, does it? Other problems. Basic physics says that energy and matter cannot be created or destroyed. If you've ever taken a physics class, you've used this fact over and over again. And almost every problem you solve, at least in a school physics class, the first thing you do is assume that energy and matter can't be created or destroyed, that they're conserved. And you write an equation applying that idea to the specific problem you have, and then you solve your problem, and hopefully you get the right answer. In fact, you may have heard Einstein's equation E equals mc squared. E equals energy, m equals mass, the amount of stuff you have, and then c is the speed of light, which is a very large number. So if you remember your algebra, that means that a little bit of mass equals a lot of energy. Now we can convert back and forth. We can convert matter to energy. And the most efficient way we know how to do that is with a nuclear bomb. A little bit of stuff turns into a lot of energy. We can go the opposite way too. You can take a lot of energy and make a little bit of stuff. They do that in particle accelerators. They get particles zipping around at close to the speed of light and smash them together. More particles come out of the collision than went in. The energy of their motion gets converted into more particles. But my point is, we're not creating the particles, we're converting the energy into them. And we're not creating the energy of the atomic blast, we're converting the energy inherent in the matter. So again, neither energy nor matter can be created or destroyed. That's why you need to eat food, because your body can't make energy from nothing. It needs to get it from the chemical energy stored in the food, which in turn got it from where? Plants, who got it from the sun, and so on. That's why you need to pump gas into your car. In fact, the fact that you're watching this presentation tells us that energy and matter are conserved, because engineers have to use this idea to design electronic circuitry. It's fundamental to a lot of the stuff you learn in circuit theory, for example. So the fact that this laptop and this projector and the lights are working tells you conservation of mass energy is true. But the Big Bang violates this. In fact, it violates it in the largest possible way. It says the entire universe sprang out of nothing. Now, if you were to go into a physics class and propose violating this idea on even a small scale, I mean, instant wrong, and you get laughed at in the classroom. Yet the Big Bang violates this in the largest possible way. Do they have a solution to this? Well, they think they do. They claim they do. They will say, well, yeah, nothing made everything. That would seem to violate the conservation of mass energy, but not really, see, because nothing made everything, but everything is really nothing. So nothing was really made. What do they mean by that? Well, cosmologists will tell you that you can model the universe in such a way that all of the stuff, all the energy and mass, equals some number. And you can model the universe mathematically that its gravitational distribution produces negative gravitational energy that just so happens to counteract the positive stuff. So it's kind of like 1 plus a minus 1 equals goose egg, 0, right? Positive mass energy plus negative gravitational energy equals 0. So the cosmologists argue that the entire universe is nothing. Therefore, there's no problem with creating it from nothing because nothing was made, nothing was created. Well, that you can write an equation that says 1 minus 1 equals 0, sure, but that doesn't mean that's a practical principle you can apply to the creation of the universe. As a refutation, I'm showing you a picture here of an audio speaker. I once worked on a project where an audio system. One part of the circuit had to produce 2 voltages to power the rest of the circuit. And those two voltages happen to be plus 40 volts and minus 40 volts. And if the negative voltage sounds weird, don't worry about it. It just means it's 40 volts below ground. But my point is, this part of the circuit was producing positive voltage and negative voltage that happened to be the exact same magnitude. I could argue that on a net basis, this circuit didn't produce any voltage, right? Using their Big Bang logic, right? Despite this fact, though, this circuit didn't work when someone pulled the plug out of the wall. In order to force the system to produce these two offsetting voltages, it needed to draw power from an external source somewhere. For that matter, it wasn't doing it spontaneously anyway. The circuit had an intelligent designer. So my point is, the universe does not spontaneously diverge into positive and negative offsetting energies. Yes, you can do that, but it requires an intelligent designer, it requires a machine to do it, and it requires an external power source to power the process. What's the external power source for the universe? There is none. Stephen Hawking gives as an analogy. He said, well, just like as a man goes and digs a hole and piles the dirt up, he said, the hole and the hill that he made will kind of offset. It's like, well, yes, Mr. Hawking, but the hole doesn't dig itself. And the man has to expend energy in order to produce the hole in the hill, doesn't he? And since there's nothing outside of the universe, by definition, you can't say the universe spontaneously split itself into positive and negative energies, because that doesn't work. Big Bang has other problems as well. It was realized fairly early on that it makes some major predictions about the universe that are not true. For one thing, it predicts the universe should be filled with what are called magnetic monopoles, particles that are magnetic with only one pole. We don't see those. Measurements of the CMB also reveal something called the horizon problem. I already told you there's patterns of temperature differences within it that don't match the Big Bang. On a larger scale, there's problems as well that you can look up the phrase horizon problem if you're curious what that is. I'm just pointing out that as we've looked at the sky and really matched it to the Big Bang model, Big Bang can't have produced that. There's also an issue in that the Big Bang should have produced a universe with either massive positive or negative curvature, but the universe apparently is flat. Now, if you're worried about what a curved universe means, that's just a geometrical measurement of the cosmos that cosmologists do. Without getting into details, point is, Big Bang says it has to be either this way or way off the other way, but instead we got something right down the middle. It's been likened to the possibility of balancing a sharpened pencil on its point for 14 billion years, in terms of how unlikely it is for the universe to have wound up exactly in the middle the way it did. Now, I'm skipping over these problems quickly because cosmologists will tell you that they have a solution to all three of those problems I just mentioned, and that's inflation. Inflation was mentioned in the evolution Achilles heel little clip we just saw, by the way. You heard Dr. Hartnett say inflation had no reason to start and it had no reason to stop. Basically, inflation is a just so story for that early in the universe's history, it started expanding and then it suddenly blew outwards at multiple times the speed of light. And then after it did that for a fraction of a second, decided it wasn't such a good idea anymore, and then it slowed down to a slower expansion rate and then continued from there. The problem is, now indeed, the idea of inflation does solve all three of these problems, which is why cosmologists welcome the idea with open arms. The problem is nobody has any explanation for how inflation could have occurred. As this article says, what drove inflation? Nobody knows. Physicists have suggested different models to describe the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet, says this particular astrophysicist. Another scientist said, inflation's theoretical underpinnings may be rather tentative. The inflaton, that's the particle that supposedly powered all this, after all, is a hypothetical field whose existence has yet to be demonstrated. In other words, they don't have an inflaton in physics. By the way, there's no room in particle physics for an inflaton either. Its potential energy curve is posited by researchers, not revealed by observation. The inflaton must somehow start at the top of its energy curve across a region of space, and so on. And in fact, this problem has actually gotten worse. And by worse, I mean recently, the last year or so, again, analyzing data from the Planck spacecraft. Cosmologists are realizing that the models that are most favored by this data, when combined with early results, suffer from exacerbated forms of initial conditions, meaning needing extreme fine-tuning, and multiverse problems, and they create a new difficulty that we call the inflationary unlikeliness problem. That is, the favored inflaton potentials, in other words, what the inflaton must have been according to the CMB data, are exponentially unlikely according to the logic of the inflationary paradigm itself. The unlikeliness problem arises even if we assume ideal initial conditions for beginning inflation, if we ignore the lack of predictive power stemming from eternal inflation and make no comparison with alternatives. Thus, the three problems are all independent, all emerge as a result of the data, and all point to the inflationary paradigm encountering troubles that it did not have before. Now, I'm skipping over a lot of detail here, as you might have guessed. The point is, more and more data is discrediting inflation more and more. But cosmologists are unwilling to give it up. In fact, you'll be told, no, we know inflation happened. Why is that? Well, because without inflation, the Big Bang would have those three fatal problems that I told you about a moment ago: magnetic monopoles, horizon, and flatness. Now, think about this. Is evidence against the Big Bang, i.e. the horizon, flatness, and monopole problems, is that evidence for inflation? Or is it just evidence against the Big Bang? Logical fallacy, right? Evidence against the Big Bang model is not evidence for an inflationary version of the Big Bang model. It's just evidence against the Big Bang model. So overall, inflation is a rescuing device meant to save the Big Bang from its problems. There's no justification for the particle physics that's meant to underlie this. No reason for inflation to start, therefore. And in fact, once you're in it, you can't stop. I'll talk more about that here shortly. Another problem that presents itself for a secular view of origins is fine-tuning. There have been entire books written on how finely tuned the Earth is to support us living here, how wonderfully different the Earth is compared to every other planet we know of. And some of these books, by the way, aren't even written by believers. We're talking secular scientists acknowledging this. Now, I've touched on that in my DVD, so I won't talk about it here. I've also touched on the fact that the sun is finely tuned as well. You can make a case for intelligent design of the sun. For example, they've recently finished a 30-year study of the sun's photosphere. It varied in its energy output by less than 1/10 of 1%. They said it was basically constant in temperature. Now, we don't blink an eye. I would say, yeah, we know the sun is nice and stable, because we're used to that. But stars don't work that way. Even sun-like stars normally produce, as this quote says, bright superflares about once every century. And a superflare is a massive eruption of solar material into space. Of course, any planet that's in the way of one of those has very unpleasant things happen to it. But a superflare has not occurred on the Earth and sun in recorded history, as far as we can tell. Now, they say why that happened or why that has not happened is unclear. Well, I think it's quite clear. Isaiah 45 says that the Lord created the heavens, formed the earth and made it, established it, created it, not in vain. He formed it to be what? Inhabited. An omnipotent, omniscient, intelligent designer, amazing engineer named God, created everything, so we shouldn't be surprised that it was well done. But those are all large-scale things, sun, earth, and so on. Even going the opposite direction, we see in chemistry evidence of fine-tuning. Sir Fred Hoyle, who is not a friend of creationism, certainly, he said that some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics. He says it seemed almost beyond question. Another scientist said this: a change of as little as 0.5% in the strength of the strong nuclear force, or just 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants appearing in our theories appear fine-tuned. If they were altered by only modest amounts, the universe would be qualitatively different, and in many cases unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. That's a bad thing, by the way. The emergence of the complex structures capable of supporting intelligent observers seems to be very fragile. The laws of nature form a system that's extremely fine-tuned. What can we make of these coincidences? Our universe and its laws appear to have a design that both is tailor-made to support us, and if we are to exist, leaves little room for alteration. I have lots of quotes like this. I won't belabor the point. You understand what I'm saying here. chemistry and physics itself, the constants within it, the forces within it, very finely tuned. Modify these by very small amounts, and very large results occur. Now, a lot of these arguments are based on the Big Bang model, meaning that if you tweak the constants a little bit, the Big Bang couldn't have made us. Obviously, I don't accept the Big Bang, but I'm presenting this to debunk the secular idea overall. It interests me that the Lord made things in such a way that even the best secular idea about how to deny what he did still produces the result that it had to be extremely fine-tuned to a 0.5% here, 4% here, and lots of other places in order for anything to have happened. So even the universe itself is finely tuned. There's now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. The more I examine the universe and the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. Among all the different ways that microstates of the universe can arrange themselves, only an incredibly tiny fraction correspond to a smooth configuration of dark energy, etc., etc. The conditions necessary for inflation to begin are extremely specialized. If you were to choose configurations of the universe randomly, you would be highly unlikely to hit on the right conditions to start inflation. What's highly unlikely mean? Well, a few years back, someone calculated that the odds of the universe being able to form itself in a Big Bang with all these fine-tuning variables go on was 1 out of 10 to the 60th power. That's 1 out of a number 1 with 60 zeros after it, whatever that number would be. I'm not sure there's a name for it. Physicist named Paula Davies offered some perspective on that. Suppose you wanted to fire a bullet at a 1-inch target on the other side of the observable universe, 20 billion light years away. Your aim would have to be accurate to that same part in 10 to the 60th. So your odds of hitting a 1-inch target on the other side of the universe is 1 out of 10 to the 60th. That's the odds of a random configuration producing this finely tuned universe. Now, this was a few years back before they discovered what they think is dark energy, which has made this problem much, much worse. Now the fine-tuning is up to 1 out of 10 to the 123rd power, meaning that you'd have to hit that 1-inch target not once, not twice, 10 to the 60th times in a row. Our universe appears surprisingly fine-tuned for life in the sense that if you tweaked many of our constants by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. Just for perspective, this is the number 10 to the 123rd. 1 out of that number is what you're looking at to produce a finely tuned universe out of the Big Bang. One non-Christian physicist said this is a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, the idea that the universe was created for humanity to live in. You can tell what he thinks of that idea by the adjectives he uses. So do secular cosmologists have a solution to fine-tuning? Well, they think they do. Their solution is that we don't live in the only universe. There is an infinite number of universes out there. This is called the multiverse. You may have heard that word. And since there's an infinite number of universes, there's going to be some unlikely ones out there somewhere. We just happen to be in one of those. Now, you may be confused because I just switched terminology on you. How can there be more than one universe? By definition, universe is everything that there is. Well, the term has been redefined. It now means, depending on the context, sometimes it still means everything, but other times it means that which we can ever perceive, even given our best possible technology and so on. So everything that's outside of our perceptible range ever is outside of our universe. And since there's believed to be stuff beyond that, they would be other universes. And then infinite number of those makes a multiverse. In fact, a cosmologist will actually tell you that the Big Bang Theory now includes a multiverse. It doesn't just require it to explain fine-tuning. It actually tells you how it got there. Because it turns out that once inflation begins, it's actually impossible to stop, and an infinite multiverse of universes is formed. And I won't read that big paragraph to you. The basic idea is inflation happens so quickly that you go from a pinpoint universe to a bubble universe very quickly. Inflation then tries to stop. Now, in the early days of inflationary theory, they said, okay, well, it starts, it stops, and then we just keep going. It was later realized that that's naive, that because of quantum uncertainty, you can't stop inflation across the whole baby universe simultaneously. There's going to be a few points within it that are still inflating even when everything else stops. The problem is inflation occurs so quickly that within a billionth of an eye blink, those little points instantly form new bubble universes again. So your original one stopped inflating and became a bubble universe. You may hear that phrase. Points within it kept inflating, produced other bubbles that then stopped inflating, but they still had points that were going. So you understand what I'm saying? You're spawning an infinite number of bubbles all across the multiverse. And this process will never stop. It can't stop. Now, what does it mean for there to be infinite universes? Well, now it gets interesting. The implications of this can be quite profound. This article said, is there another copy of you reading this article, deciding to put it aside without finishing the sentence while you are reading on? A person living on a planet called Earth with misty mountains, fertile fields, and sprawling cities in a solar system with 8 other planets. The life of this person has been identical to yours in every respect. Until now, that is, when your decision to read on signals that your 2 lives are diverging. You probably find this idea strange and implausible, but it looks like we'll just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a galaxy quite a ways from here, but still exists. This does not even assume speculative modern physics. Merely the space is infinite and rather uniformly filled with matter, as indicated by recent observations. Your alter ego is simply a prediction of the so-called concordance model of cosmology, which agrees with all current observational evidence and used as a basis for most calculations at conferences. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many Earths with people with the same appearance, name, and memories as you. So there's an infinite number of planets where this exact conversation, this exact presentation is going on right now, all through the multiverse. Now, there's also an infinite number that are almost exactly the same, but you, sir, had something different for breakfast this morning. And then pick, all of you. There's universes out there where the South won the Civil War. There are universes out there where there never was a civil war because the original 13 colonies lost the revolution against King George III. On and on and on it goes. Every variation of possible history you can think of is out there somewhere, an infinite number of times. And since even the most unlikely events must take place somewhere, yes, this universe is outlandishly fine-tuned and outlandishly unlikely to have formed, but because in an infinite number, even the most unlikely thing will happen somewhere, this one did, and that's just where we happen to be. And multiverse is big business nowadays. If you want to make some money, just go write a book about all these other universes that no one can observe, because who can prove you wrong, right? Our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The universe is not some kind of optional thing like can you supersize or not, says this theoretical physicist. Our own history tells us that it's there and we need to deal with it. So even if the idea seems strange to you, you better just deal with it. So, we've talked about why the Big Bang is claimed to be good science. We've seen reasons to argue that it's actually bad science and that you wind up in this multiverse thing as your logical result of it. Part 3 of this is to take it further and say, if you take the Big Bang to its logical conclusions, it's actually anti-science. And I'll give you 5 separate reasons why. Number 1, it violates physics. Any quote-unquote scientific model that violates the conservation of mass energy is a non-starter out of the gate. I mean, forget it. You've just violated the most important thing in physics, and where can you go from there? Everything can't come from nothing. Number 2 is a little more subtle. It not only violates physics, it invalidates physics. What do I mean by that? Well, if the Big Bang was the beginning of everything, space-time, not only space but also time, which is what the Big Bang says, then there was no time before the Big Bang, like we talked about. Therefore, what caused the Big Bang? Nothing. Nothing could have, because A, there was nothing to do it, and B, there was no time within which to do it. A cause has to come before its effect. And the Big Bang can't be an effect of anything because the cause would need to come before it, and there was no before the Big Bang. So the Big Bang had no cause. famous quote from a cosmologist said, "The universe is just one of those things that happens from time to time. There was no reason for it to happen. It was just a random event." Is this a scientific argument that it just happened? Or is this a denial of scientific reasoning? Now, the reason I'm bringing this up is, if the entire universe was founded in a random event for no reason whatsoever, what right would you have then to expect it to operate strictly according to laws of physics from that point onward? Is that consistent or inconsistent? It's inconsistent. Now, Christians don't have this problem because we believe in a God that upholds the universe by the word of his power, who promised that the world will work according to certain patterns. Now, of course, he can intervene in the form of a miracle if he chooses to, but the point is the Bible talks about things operating regularly. We have a God who is upholding the universe, and so as Christians, we can do science and say, yes, we can reasonably expect the universe to operate according to laws which we can seek out through science and find. An atheistic Big Bang believer, though, really can't do that. He believes in a universe that was founded in randomness and chaos, happened for no reason whatsoever. Doesn't really have a reason to expect the universe to operate according to laws of physics from that point on. Now, there are many atheists who are scientists and many atheists who are good scientists, but my point is they're not good scientists because they're atheists. They're good scientists in spite of their atheism, because their atheism is fundamentally incompatible with expecting the universe to be orderly. And you need an orderly universe in order to do physics, right? Next, let's see. Running short on time here. Let me skip a little bit. Reason 3 is that the Big Bang is self-contradictory. I've told you that the Big Bang now involves inflation, which results in the multiverse, which by definition is all these universes that we can't see. So if all those universes are unobservable, even in, not just because our telescopes aren't good enough, even with the best possible telescopes, these other universes are outside of our capability to observe. If something is unobservable, if it's outside the natural world, what word do we use for something that's outside of the natural? Supernatural. Which is the reason that biblical creation is disallowed from the discussion, right? Multiverse, by its nature, is a supernatural explanation, right? By definition. And even some secular scientists are unhappy about this. These multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination, unconstrained by evidence. My own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks. We don't know anything about that, do we? And becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience. Moving on, the Big Bang has absurd consequences. If your model makes absurd predictions, then that makes your model absurd. In fact, the Bible says, by their fruits you shall know them. What are the fruits of the Big Bang model? Good predictions or absurd predictions? Is the Big Bang science or science fiction? Well, let's see. I'm quoting now from a variety of explanations for some of the problems that I've been explaining to you, and there's more where these came from, but this is a sampling. Some people are now trying to explain away the fine-tuning of the universe with things like this. Maybe we should approach cosmic fine-tuning not as a problem, but as a clue. Perhaps it's evidence that we somehow endow the universe with certain features by the mere act of observation. It's an idea that Stephen Hawking has been thinking about too. Hawking advocates what he calls top-down cosmology, in which observers are creating the universe and its entire history right now by looking at it. If we in some sense create the universe, then it's not surprising that the universe is well suited to us. Science or science fiction? Others are trying to get rid of a beginning because that smacks too much like Genesis. And they say things like this: our universe may be the offspring of some other universe. Baby universes fluctuate into existence in both directions of time, eventually emptying out and giving birth to babies of their own. On ultra-large scales, such a multiverse would look statistically symmetric with respect to time. Both the past and the future would feature new universes fluctuating into life and proliferating without bound. Each of them would experience an arrow of time, but half would have an arrow that's reversed with respect to that of the others. In other words, universes are birthing each other, and new baby universes are popping out all over the place. Oh, but by the way, in half, for this idea to work, in half of those universes, time flows backwards. That's science or science fiction, right? Others are dealing with, well, multiverse would have interesting implications for history. For example, there's no dinosaurs on this planet because, according to evolutionists, they all went extinct 65 million years ago due to a freak event like an asteroid collision or something unexpected. But in other planets, these freak events wouldn't necessarily have occurred, and dinosaurs would have kept evolving. So scientists a while back, a very accomplished one, by the way, published an article that talked about going to other planets and noticing that other life forms on these planets could well be advanced versions of dinosaurs. Assuming that mammals didn't have the good fortune to have the dinosaurs wiped out here, we would be better off not meeting them. Because there's nothing worse than running into a dinosaur that has better weapons than you do, right? But if the multiverse is true, is this a joke? Or is this infinite number of planets with technologically advanced dinosaurs? Right? Science or science fiction?
Look out! There comes another one. I got him.
I couldn't resist. Others are blaming aliens for our universe being here. It is proposed that our universe was created by life of superior intelligence existing in another physical universe. Intelligent beings, perhaps our own descendants in the future, might possess not only the knowledge to design, but also the technology to build universes. This explains why the constants of physics have their observed finely tuned values, because the aliens are good designers. It might even help us to understand why our universe is comprehensible to the human mind. Now, is this science or science fiction? Anyway, others are saying, well, maybe our universe isn't actually real anyway. Maybe our universe is actually a simulation being run on alien computers. It is a perfectly acceptable supposition that the world as we now know it is a vast computer program run on machines built by an intelligence we know nothing about, in a universe that could be like any of the ones we speculate about, or one that's totally strange and alien. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes, there would, in all probability, be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of the universe. Because in a multiverse, there will be an infinite number of universes where aliens have the technology to build universes. So chances are that's where we are. So in other words, we see the cosmos, but we're not really looking at a cosmos. We're actually looking at a computer simulation being run on alien computers. Now, I hear people laughing. I mean, this sounds pretty silly, right? Oops, that didn't work very well. That's better. But you need to stop laughing because this is a serious matter.
This is a serious matter.
Right? Cosmologists are seriously working on trying to figure out if our universe is a numerical simulation run on an alien computer somewhere. Oh, by the way, this is partially funded by the U.S. Department of Energy. These are your tax dollars at work, people. But is it science or science fiction? In fact, let's think about this. If there are universes out there with aliens with such super-duper technology that they can simulate universes, then there must also be aliens who have such super-duper technology that they can run simulations of universes that contain aliens running simulations of universes, right? And I didn't make this idea up myself. There could even be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. So, not only is our cosmos not really a cosmos, it's actually a simulation running on an alien computer, but so is that one. That one is inside this one, and that in itself is, of course, a simulation that's being run on a different computer, which is itself part of a simulation running on a different computer, and on it goes. right? Now, do I even need to ask by this point, science or science fiction? But isn't this where the multiverse takes you? It brings you into complete absurdity. Why then do secular cosmologists who, on a whole, well, for the majority anyway, are very intelligent men and women, why do they buy into this? I mean, they're not stupid. They know where this ultimately winds up. Well, because if there's only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. Psalm 14 says, "The fool says in his heart, there is no God." Now, I'm not calling these scientists fools. Again, they're very intelligent people. But when you deny the truth, you must end up in a lie. When you deny creation, you must end up in folly, which is where they wind up. And you can have some fun with this, too. If you ever get in a conversation with an atheist talking about the multiverse, whatever, invoking this, you say, okay, wait a minute. I disagree with all that, but let me ask you something else. If you read Richard Dawkins' book, The God Delusion, where he says there almost certainly is no God, in fact, he has a chapter title by that, do you agree with that statement? He'll probably say yes. Say, let me reword it a little bit and be more specific. Do you believe that it is most unlikely that the God of the Bible exists? He'll say yes. Well, fine. A moment ago you told me you believe in a multiverse, and in a multiverse, even the most unlikely events must take place somewhere. And if it's most unlikely that God exists, in a multiverse he does exist. You see where I'm going with this? You can use multiverse logic to prove anything, which means ultimately it proves nothing. My last reason that the Big Bang Theory ultimately is self-refuting. It knocks itself out. What do I mean by that? Well, there's a dirty little secret in cosmology called Boltzmann brains. And if you want more detail on this and how it works, ask me in Q&A. I'm just here briefly now. Here's a summation from the New York Times. It could be the weirdest and most embarrassing prediction in the history of cosmology, if not science. If true, it would mean that you yourself are more likely to be a momentary fluctuation in a field of matter and energy out in space than a person with a real past in an orderly star-spangled cosmos. Your memories and the world you think you see around you are illusions. This bizarre picture is the outcome of a recent series of calculations that take some of the bedrock theories and discoveries of modern cosmology to the limit. The basic problem is that it's hard for nature to make a whole universe. It's much easier to make fragments of one, like planets, yourself in a spacesuit, or even, in the most absurd and troubling example, a naked brain floating in space. Nature tends to do what's easiest from the standpoint of energy and probability, and so these fragments, especially the brains, would appear far more frequently than real full-fledged people, or universes, or than us, and they may be us. Alan Guth, cosmologist at MIT, who's a rock star among cosmologists, by the way, who agrees this is absurd, pointed out that some calculations result in an infinite number of free-floating brains for every normal brain, making it infinitely unlikely for us to be normal brains. Now, here's what we're saying. I'm not talking about a brain floating in the cosmos. There is no cosmos. It's only the brain. The universe is an illusion that the brain is experiencing because it's creating false input that it interprets as senses. Now, again, I can give more details in the Q&A about why the Big Bang model says this. My point for now is, think about this. If it's infinitely unlikely for us to be normal brains, and it's infinitely more likely for us to be Boltzmann brains, then there is no universe around us, because that's all an illusion. And if there's no universe, then there was no beginning to the universe. And if there's no beginning to the universe, then there was no Big Bang. So the Big Bang model, taken to its logical conclusion, says it's infinitely unlikely that the Big Bang occurred. The Big Bang model disproves itself. So those who think they can use secular cosmology as a weapon against Christianity ultimately are using this. As Romans 1 says, professing themselves to be wise, they became fools. So I'm running out of time here. Brief review as we talked about a lot of different problems that the Big Bang model has. I hope by now it's clear this is not, as is commonly portrayed, a battle between religion and science. It's not a matter of ignorant Bible thumpers on the one hand, proclaiming that the Bible must be true despite what science says. No, I'd say science debunks the secular side of things. In fact, again, secular origins models taken to their logical conclusion deny the fundamental requirements for science itself to work. However, a worldview based on the Bible provides a universe of order, provides a reason for design, provides a reason for fine-tuning, and a lot of other things that I don't have time for tonight. By the way, if anybody's maybe a little south of here, I'm giving a whole talk, the one Heinz mentioned, next week in Mount Lake Terrace. The title of that one is Defeating Atheism with Science, showing 7 different reasons why, if you're an atheist, you should expect science not to work. And specifically, the only worldview that does provide a justification for science is Christianity. Not Islam, not Buddhism, no other option. Christianity provides foundation for science, and nothing else does, and atheism especially does not. Earlier I mentioned I would talk briefly about Christians and the Big Bang. I hope it's clear by now, number one, the Big Bang is not good science, so we shouldn't accept it anyway. It also is based on anti-theistic foundations. I mentioned earlier that Edwin Hubble interpreted redshift data to a certain way to produce galaxies moving apart in certain directions. That's not the only way to interpret that. He chose the interpretation that he did because he didn't like the idea of there being a special place in the universe, because if we were in a special place, that would make us special. He didn't want that. He talked about the horror of being in a unique position. Christians, however, should have no problem with being in a special place. I'm not saying we're the center of the universe, don't misunderstand me, but I'm saying that the universe can have a structure that the Big Bang must deny. Also, there's the idea that even if science did seem to support the Big Bang, which it doesn't, we still shouldn't buy into it anyway, because science changes. Scientific models change, I should say. As an astronomer friend of mine likes to point out, all theories have shelf lives. The Big Bang is starting to stink pretty bad, as hopefully I made it clear. It's got bandage upon bandage upon bandage. A lot of secular people are unhappy with it even. Some people are getting rid of, would like to dump it, but don't have an alternative to flee to. As soon as they do, a lot of people are going to flee. And Christians who base their ministries or their worldviews or their teachings on a secular scientific idea that can be abandoned tomorrow are building houses on quicksand. Better to affirm that in the beginning God created the heavens and the earth, because indeed the heavens do declare the glory of God. I have a newsletter. If you like astronomy from this perspective, this has been a much broader cosmology than a lot of the stuff I do, but typically as discoveries in astronomy are announced, like you see this particular issue here was about Mercury. This is a free email newsletter. If you'd like to get a unique perspective on things, you can sign up for that at my website, creationastronomy.com. Heinz also mentioned I have a couple DVDs back there. This is the one I mentioned earlier that goes planet by planet and shows how each one discredits secular origins models. Number 2 does the same with stars and galaxies. And I believe we are opening up for questions now. Thank you for your attention.
Thank you, Spike. Let's give Spike a hand for that.
Thank you.
And we do have some time for questions. But while you're thinking of your questions, I'm going to ask the 3 ushers to come up. We're going to take a free will offering for those that would like to help us run this ministry. We'd appreciate that. Don't feel compelled, but if you're going to do that, you're welcome to do that. So I'm going to run the mic around, and for those that have questions, put your hand up, and I'll bring the mic by you, and you can ask your question.
Yes, I saw on YouTube a discussion between Russell Humphreys and John Baumgartner, and they were discussing the fact that the majority of scientists have a misunderstanding about what the theory even is, and this idea about the Copernican principle and that we can't be in a special place and all that. Mm-hmm. But they referred to the question of does the universe have a center and does it have edges? Could you talk about that a little bit and what the misunderstanding is about the Big Bang in that respect?
Okay, so we observe redshifts all around us. That means galaxies are moving away from us. There's a few close by ones that we're in a group with that aren't doing that, but everything further out is all moving away. And the farther out it is, the faster it's moving away. Now there's 2 possible options. Well, let me put it this way. We appear to be at the center of an expanding universe. So there's 2 possible options. A, we appear to be at the center of an expanding universe because we are. Or B, we appear to be at the center of an expanding universe, but it would look that way regardless of where you were within the universe. Hubble chose option B. And the cosmological principle is the idea, as you touched on, that there's no center and no edge to the universe because there can be no special place. If there can be no special place, then there can be no center because the center would be a special place, and there can be no edge either because that would be special compared to somewhere else. So the universe can have no center and no edge, and they make that fundamental assumption and then build, with Einstein's relativity, cosmological models. But that's an assumption because we've never been outside of our solar system, never mind our galaxy or galaxy cluster. We have no observational way of knowing what the universe would look like from way over there. So they assume that it would look the same from anywhere, and in fact, frequently in science articles, it's presented as a discovery or an observation. But it's an assumption. It's not either of discovery or observation. It's merely an assumption. If you make the different assumption that maybe we appear to be at the center of an expanding universe because we are. Now, we don't have to be at the exact center, but just somewhere close enough to it for it to look this way. Then you apply relativity to a model of the universe, you get a much different picture. Now you start having gravitational wells. You can have a center of mass and all sorts of other things, and then several creation cosmologies are built on that. And tonight I didn't have time to talk about a creationist view of cosmology. We could do a whole presentation just on that. Like I mentioned at the beginning, I'm focusing on debunking the secular side of things. But physicists who are Bible believers have questioned the assumption you're bringing up and saying, well, why can't there be a special place? I mean, the earth is apparently the center of God's attention. You know, the Lord took on human flesh and came here. That's, you know, very much special attention. So maybe we are at a special place, and if so, what would that look like? And then you apply the math, and you wind up with a very different model of the universe, where, among other things, you can have starlight come from objects that are millions or billions of light years away, yet a clock on Earth has only measured 6,000 years since creation. So it all keys back to that initial assumption. So thank you for bringing that up. Yes, sir.
So what year approximately did this theory of the Big Bang come into effect?
It was around in the 40s and 50s, but it wasn't really popular. Steady state tended to be the more dominant one, which says that the universe is eternal. It was the discovery of the cosmic microwave background in 64, 65 that really boosted the Big Bang up, and the other secular cosmologies sort of fell by the wayside. Because the other ones couldn't explain the CMB, but the Big Bangers had predicted it. So the model really took off in the mid-60s, and it's been pretty much the dominant one ever since.
Let me just add you know of that book, The Privileged Planet, that discusses some of the issues you were talking about, the fine-tuning.
Oh, yes.
And also, you know, we're at the center, or close to the center of the universe.
I don't remember it talking about that.
Yeah.
That would surprise me, because Guillermo Gonzalez, to my knowledge, wouldn't believe that.
Yeah. It discusses that.
Okay, well, I haven't.
Okay, any other
A number of years ago I saw that.
questions?
Surprised nobody asked about Boltzmann brains. I have a couple minutes. Do you want to hear why the Big Bang model says such a ridiculous thing? Yeah? I mean, because it'll help you share the idea with others, if nothing else, which is one of the reasons we have these meetings. Okay, so imagine you're a scientist in a lab, and here's your lab bench, and you're studying gases. So you've got like a glass aquarium, and there's some gas in there, air, whatever it may be. And it's sealed all the way around. And you've got various instruments that measure the density and temperature and pressure and everything else. And you're in there that morning, and you look at all your instruments, and you see there's uniform pressure throughout the whole system, okay? You turn your back, and you're doing some other stuff, and you turn around, and you notice your instruments are registering a higher pressure, denser spot right here. And then as you watch, it dissipates until it's all equal again. So what's going on here? Well, the first thing you do is you go look and you make sure that there was no external thing that could have caused this little dense patch in the gas. So for example, this room, there's all gas molecules in here. They're all bouncing against each other. There's, you know, however many gazillions of them in here. The air pressure in here is roughly equal, right? Now, it's not impossible, in theory, that they could make smaller clumps of higher dense gas here and there. In fact, they're probably doing that. It's just below our ability to perceive that. What's the likelihood, though, that as they're all moving around, bouncing off of each other, that they're all going to wind up in that corner of the room and leave the vacuum out here for us to be gasping for air? That's possible, but very, very unlikely. In fact, you'd have to wait billions of years for a room to this size to even, you know, have a chance of doing such a thing. Well, you know all this in your mind, so you're looking at this aquarium, you say, okay, there's this dense patch that's then dissipated. Now, the dissipation doesn't surprise you because that's how gases behave. You know, if I have a can of compressed air and I spray, it's higher dense, some of you have seen this demonstration on my DVD or whatever, you spray compressed air, it goes from a denser system to a lesser denser system, it equalizes itself, right? It doesn't go the opposite way. It goes from denser or higher pressure to lower pressure. Well, same thing here. Once the higher pressure clump in the thing was formed, it then dissipates till it's all even again. But you've checked, and there's nothing that could have caused this in your lab. There's no external source of heat, or there wasn't an earthquake. I mean, you think of all the possibilities, and they're all not. So you're forced to conclude that just as the molecules are moving around, bouncing off each other, they all just happen to wind up in a more localized clump and dissipate. Or is that really what happened? Do you instead conclude that what really happened was a much, much denser clump formed when your back was turned, and that was what was in the process of dissipating when you turned around? You understand the two options? Option number one is that the clump formed and then dissipated. Option number two is that a much, much denser clump formed and was in the process of dissipating back when you turned around and saw it in the middle of that process. Is everybody confused yet? My point is, it's unlikely for that clump to have formed, but you're forced to acknowledge, well, apparently that's what happened because there's no other reason for it. You're not going to accept, though, that it was actually a much denser clump when your back was turned, because that's exponentially more unlikely. If the slightly dense clump is exponentially unlikely to have happened, the far denser clump is exponentially unlikely. See the logic so far? Now apply this to the universe. If the universe fluctuated into existence, what is the likelihood that it would have formed something 14 billion years ago that evolved to the universe we are in right now? Thermodynamics says entropy will always increase. Now, physicists have taken thermodynamics and applied it to different ways. One of the implications is, in effect, things get less and less complicated, if I can use that. Statistically, things get more and more likely over time, is another way of putting that. So if the universe has been around for 14 billion years, and its complication level today, its unlikeliness is, whatever number, express that as entropy, it must have been far more unlikely 14 billion years ago. So the analogy is, you just turned around in your lab and you see today's universe sitting there. Do you say it fluctuated to this density, which is already unlikely enough? Or do you say it fluctuated to this far, far, far more unlikely little clump where all the gas was in one corner and the vacuum everywhere else, and then it's dissipating back, and that's when you turn your back? You see the analogy now? Today's universe, as complicated as it is, I mean, as complicated as our brains are, 7 billion people in the world, each with this amazingly complicated mass of tissue in our skulls. As complicated as the universe is today, as unlikely as the universe is today, it would have been far more unlikely 14 billion years ago, because statistically it has to get more and more likely as time progresses. Have I lost anybody yet? Most people. Anyway, point is, as unlikely as it is for the universe to have suddenly popped all of us into existence 10 seconds ago, where you didn't actually come in here and watch the presentation an hour ago because that's all an illusion, it's a false memory that came with your brain. In fact, you can't even be sure anybody else exists but you. You might be the only one. There's one brain, everybody in this room is an illusion. Your entire lifetime to this point is a false memory. That's all part of the illusion. Not that it matters, because you're about to fluctuate back into thermodynamic soup anyway in a few seconds from now. But that is far, as unlikely as that is, for a brain to pop into existence with false senses and false memories and illusions, that is far more likely to have happened than the entire universe to have popped into existence 14 billion years ago and get more and more statistically likely over time to where we are. Does that make sense? Or did I just lose everybody?
I think
it's a strange idea, but when you really grasp, well, okay, I'll shut up.
you have tackled one of the most difficult sciences, of course. In creation, the three big things that I see is biology, geology, and astronomy/cosmology. Of those three, this is the most difficult one. So I laud you for tackling this one.
For being so foolish as to, hey, angels fear to tread, let's go.
Yeah. But again, let's give him a hand for his presentation.
Thank you. Thank you for having me.